Hello and welcome. In this video, I'm going to go over two limiting reagent questions. The first one begins with just being asked to determine which of the two reactants is a limiting reagent. The second question then asks you to figure out the mass of a product, which means you then have to determine first which of the two reactants is the limiting reagent. Right, so let's start with the first question. Okay. Um, always verify that your reaction is balanced. In this case it is, and since I copy and pasted this from a Google form check-in quiz, the subscripts here of course are not subscripted, so I'm going to rewrite this right now. Okay, so there's our balanced equation. I'm going to use this again as I've done in the past as a table. So the question has given us a bit of information here. So it says to simply determine what the limiting reagent is. It's not asking us to figure out which product, so it's just which of these two is our limiting reagent. And we have this information. There's 80 grams of I2O5, so we write that down, 80 grams, 80.0, so there are really 3 sig figs here, but I'll just write 80 for now in this table. So 80 grams and 25 grams of carbon monoxide. Okay, so always figure out the number of moles, right? And that we know to be mass divided by molar mass. So we get 80 grams and 25 grams for carbon monoxide. We're going to divide each of these by their molar masses. Okay, so here we have, I'm going to highlight this, we have the number of moles of I2O5 and the number of moles of carbon monoxide. Okay, now we can't just compare these two and say, well, this one appears to have less, so that's our limiting reagent, because they don't exist in a 1-to-1 ratio. We can't do that. We have to put them on the same playing field, same level playing field. So what we're going to do is what I call the hypothetical situation test. That is, we're going to pick one, and it doesn't matter which one, so that we can determine then how much of the other we need. Okay, so let's do that here. We're going to figure out hypothetically how many moles of I2O5 we would need, knowing that we have this many moles, but we're going to see how much we would need in this mole ratio. All right, so we're going to begin with what we're given, 0.8929 moles of CO. Multiply that by a conversion factor, our mole ratio in this case, right? Mole CO at the bottom, mole I2O5 at the top, and because this is our mole ratio, we look at our coefficients, and here is 1, here is a 5. Right, then we do the bit of math here. These cancel out, these units cancel out, and we get 0.785 mole of I2O5. Okay, now we have to compare. This is how much I2O5 we need, and this is how much I2O5 we have. So we can say since there is more, that's more. But let's make that look a bit more legible. Since that's also is, since there is more, so since there's more I2O5 than we need, look, we're going to compare this again. We have 0.2396. We need that much. Therefore, we can say that I2O5 is our excess, which means carbon monoxide is our limiting reagent. So therefore, our limiting reagent in this case is carbon monoxide. And we're done the first question. Okay, next. scroll down a bit. Okay, next question. We're going to rewrite this reaction, but essentially it's a limiting reagent question. We know this because we're given the mass of both of our reactants, aluminum and sulfur. It's producing aluminum sulfide. I'm going to rewrite this so we can organize all of our information here. So 2 aluminums, 3 sulfur, create Al2 S3. Okay, and we're given masses of both reactants, that is 5 grams and 10 grams. Right, always convert to moles. Okay, so you're again going to just do mass divided by molar mass. Right, the molar mass of aluminum is 26.98, depending on what periodic table you use, although it should be very similar. Okay, that's the number of moles of aluminum. We'll do the same thing for sulfur. So it's 10 grams divided by 32.06 grams per mole. Right, and we get 0.3118 moles. Okay, so this is what we have. We have that many moles of aluminum and that many moles of sulfur. Now, one of them is going to run out before the other. And it's not possible to just compare them at face value one to the other because it's in a 2 to 3 ratio. So we have to do a little bit of math. Now there are several ways to do this. I'm going to stick with the hypothetical test method, but you could. The other ways are another popular one is divide this by 2 to figure out how many you need per mole. Divide that by 3, then you can compare. That's one way. You can then figure out. Another way is just to pick one at a time, figure out how much product can be made, then choose one that makes the least product. That's a bit, I don't know, I think that's a bit too much work. I think I like this way better, but whichever way you decide to choose, it's up to you. We're going to use the hypothetical test method. All right, so let's figure out how many moles hypothetically we need of aluminum. All right, despite having that, we're going to figure out how much we would need given this ratio. So we have 0.3118 moles of sulfur, right? We need to figure out how many moles of aluminum. So we're going to have to eliminate sulfur, so that goes at the bottom. Aluminum goes at the top. Sulfur, there's a 3 in the balanced equation. Aluminum, there's a 2 here. So cancel. That number times 2 over 3 gives us 0.2079 moles of aluminum. And now we can compare. Okay, we're going to compare this value of aluminum to this value of aluminum. And we see that we don't have enough. Look, given this information, given that many number of moles of sulfur, that much sulfur, we would need this much aluminum. So since there is not enough aluminum, therefore aluminum is our limiting reagent. Okay, so now this has become a stoichiometry problem. We can go back and solve this. Because we know what our limiting reagent is, it's aluminum. We're only going to use aluminum's number of moles to figure out what the mass is. And I should have written this down. Here is what we're being asked for, right? The number of moles, the mass of product aluminum sulfide. Okay, so the stoichiometry portion is this. And let's continue to use a factor label method. We need to figure out how much product we are going to have. We now know to use just the aluminum, the number of moles of aluminum. Multiply that by a conversion factor. We have to get rid of aluminum, so that goes at the bottom. And aluminum up. at the top, aluminum sulfide at the top. So this has a coefficient of 1, and that has a coefficient of 2. Again, units cancel out. Do a bit of math here, and you get 0.09265. Okay, we're almost done. The question isn't asking us for the number of moles of aluminum, although we do need that to get to what it's asking us. It's asking us for mass. So mass is equal to moles times molar mass. We now know how many moles of aluminum sulfide we have right here. I'm going to multiply this by the molar mass of aluminum sulfide, which is, looking at the periodic table, 150.158 grams per mole. And we get a final answer of 13.9121 grams. Let's look at our coefficient, rather our question for 3 sig figs. Looks like we need to round this to 3 sig figs, which would mean an answer of 13. Just going to underline the digits, 13.9 as our final answer. Okay, hope this helped. I'll continue my next video with one more question.